All right, so I just wanted to go through and do a little recap of what we did in class today. So first one is we went through question 8, did this together, so just to go back through it, we're trying to show that this shape is a rhombus, and we knew already from the given that these two sides were parallel and these two sides are parallel. So we talked about the 4 ways to get to be a rhombus. The first one being to get all sides are equal. The second one is to get a parallelogram first, and then to get two sides that are next to each other congruent. And because it's a parallelogram, then that forces all of them to be equal. So that's the theory behind that one. Third one is to be a parallelogram and then have the diagonal bisect one of the angles. And as long as you get one of the angles to be bisected, once again, because it's a parallelogram, that forces them all to become bisected. And then the last one is to be a parallelogram and have the diagonals that you draw and create right angles here. So they're going to be perpendicular. All right, so 3 of them involve getting a parallelogram first, and then one of the properties of a rhombus, and the other one is to get all the sides equal. So this first shape, if we want to show this as a rhombus, the first thing we should notice is by the givens, we already know that this shape, ABCD, is a parallelogram. And the reason is it has the characteristic of opposite sides are congruent. Sorry, not congruent. Parallel. Once we know it's a parallelogram, and this part tells us that this is cutting this angle in half, we now know it's a rhombus because if this is bisecting this angle, that's one of the properties of rhombus. A diagonal bisects the angle. There's our diagonal, and it's cutting the angle in half. So now we can say that ABCD is a rhombus. Okay? And we're just going to put down for ourselves, we have a parallelogram this time with diagonals that bisect the angles. Okay? And we can just leave it like that. You can add is a rhombus. It's up to you. There's your justification. We're good to go. I'll put is a rhombus. I like how that reads better, but I'll leave it up to you guys. Okay? So that was number 8, and that's all it took. Number 9 on the next page. Okay, same concept here. So we're starting with a square. So this time the idea is we have a special shape. And remember, squares, keyword, okay, there's 11 properties now that we can use because it's a square. The 6 for parallelogram, the 3 for rhombus, and the 2 for rectangle. The other keyword we're going to notice here is midpoint. So remember, your keywords help you build new statements. So if E is the midpoint, that's going to tell us that BE is going to be congruent to EC. And the reason is just definition of midpoint. So there's my keyword. I created a new statement, and now I'm good to go. Now I'm going to go look at my proof statement in my picture. In my proof statement, I'm trying to show that these two triangles, right, triangle ABE, is congruent to that triangle ECD. So now I'm going to use this other keyword square to help me build new statements. Remember, in a square, all the sides are equal. So that means that this side is going to be equal to this one. So for 3, we're going to get BA is congruent to CD. And you can either just say all sides, or even in this case, just opposite sides is fine, okay, are congruent in a square. All right, and then from here, we need to use these two angles, because in a square, these are right angles. So we have 2 options. We either can say angle B is equal to 90. Sorry for the crowd noise going on in the background there. And angle C is equal to 90. Or we can say that angle B and angle C are right angles. Okay? So if you're using 90 degrees, we're just going to say, remember this time, just like in a parallelogram, we would say like in a parallelogram, opposite sides are congruent. Now we have a square. So we're going to say in a square, okay, all angles are, and then insert blank, 90 degrees, right angle, depending on what you want to do. And then for number 5, we're going to say that angle B is congruent to angle C. And this is just substitution. It's also the transitive property, don't forget that, okay? And now, do we have enough to get the triangles congruent? We sure do. So now we can say the triangle ABE is congruent to triangle DCE. And this is going to be side equal side. And that's it for that one. Okay, so for homework tonight, I'm asking you to do 2 questions. First one is number 10. Now, number 10, we're going to start with the fact that this guy is a rhombus. And we know already also that these 2 segments, UR and VR, are equal. Okay. Now, what we want to try to do is show that this segment PU, okay, is equal to this segment PV. And what should kind of catch your eye here is if I'm trying to show that these 2 segments are congruent, that they're parts of triangles. So what I really want to do is get these 2 triangles congruent. So I need to get triangle PTU congruent to triangle PQV. And if that can happen, then we can do the old CPCTC to get those congruent. So let's go back to our key thing here, right? It's a rhombus. So what's special about a rhombus, right? Well, a rhombus is a parallelogram. So, right, what do we know about the opposite angles, okay? What do we know about, if it's a rhombus, all the sides, all right? And the big thing here, and this is the key concept, is that because all the sides are equal, we're going to know that this side, TR, is congruent to RQ. And we need to use these 2 congruent pieces to get these 2 guys and the triangles congruent. And to do that, we're going to have to subtract them. We're going to have to take TR and take away UR. And on the same thought process, we're going to take RQ and subtract away our VR here. And to remember, when you subtract something away from both sides of an equation, that's a subtraction property of equality. And then we're going to substitute in the fact that this is equal to TU, and this is equal to BQ. And now we have, with segment addition, the 2 parts of our triangles congruent right here. And remember, along with this step, we can also add in these other 2 sides, PT and PQ, and now we'll have enough with our missing angles here, right? Getting those 2 angles here congruent, we'll have enough to get this thing to be, these 2 triangles being congruent, and then CPCTC this. So that's the idea behind it. So good luck with everything. And then make a right at the end of the hall. Okay. And the last one for homework is number 13. And this is the same kind of idea as the last proof. We're starting with a few things. Number 1, we're starting with the fact that we have a rectangle, and and that we have these 2 angles over here equal. So this angle ADG and then BCG are equal to each other. And we need to get these 2 small little pieces here to be the same, right here and right here. And so the concept here is that I actually need to get these longer legs, these parts EB here, and this segment AF to be equal, okay? If I can show that these 2 segments are equal, I can just subtract out the middle, and I'm left with these 2 pieces down here, okay? So how do we get these 2 segments to be equal? Well, what we really need to do is focus in on these triangles right here. So if I can show that this triangle is equal to that one, right? Then we can do CPCTC, and then we can subtract out EF. So remember, the concept here is we're going to have to take AF, set it equal to EB, and then we're going to have to do AF, subtract away EF, and make it EB minus EF. But remember, before we can take away EF, we have to do that step in the middle that says EF is congruent to EF. That silly step that we talked about before, right? Okay? And then this will leave us with our proof statement. So work towards getting this triangle congruent. You already have an angle. Remember, it's a rectangle, so what else is special about a rectangle, right? These guys right here, and these guys right here, and you should be in business, okay? I'll leave you guys that for homework. I'll finish up the rest of the questions on another video, and I'll send those out.